In this video, I'm going to talk about the derivative of inverse trig functions, okay, inverse trigonometric functions. So you have seen the trig functions in your trig class, okay. So let me review what you saw there. So for y equals to sine x, the notation for inverse of sine is we call y equals to arc sine x, or y equals to sine and then there is a -1 exponent and then x. We call sine inverse x, okay. Similarly, for the y equals to cosine, the notation is y equals to arc cosine x or cosine inverse x. So the domain, the values of x here is -1 through 1 for sine inverse x, and the range is the value of y is -π½ to +π½ including those, okay. Similarly, for cosine x, the inverse is cosine inverse, and the domain, the value of x is -1 through 1, and the value of y will be 0 through pi including the boundaries, okay. And also for tangent x, the inverse, the notation is arc tangent x or tangent inverse x, okay. The domain is -infinity to infinity and the range is -π½ to π². Similarly, these are the definitions of the inverse functions you saw in the trig class, okay. On this class though, we'll try to find out the derivative of these inverse functions, okay. For simplicity or for convenience, I want to use -1 exponent for the inverse instead of arc, but you can write arc sine inverse, arc sine x, that's perfectly fine. So I want to find out the derivative of find the derivative of y equals to sine inverse x. That's what I want to find out, okay. So y equals to sine inverse x, I want to find out y prime. The derivative is basically you want to find out y prime or dy over dx. You want to find out that, right? So how do I do that is you start with y equals to sine inverse x, right? And then this can be written as, if you take sine on both sides, what do you get? You get sine y equals to sine and then sine inverse x. The sine and sine inverse will cancel out, right? So what you get is sine y equals to x. You see that? Now you want to find out the derivative, okay? So how do I find out the derivative here? Is differentiate on both sides will give you d sine y over dx equals to dx over dx. I'm finding the derivative with respect to x. You see that? There is y sine y, there is x. So they don't match, right? So we need to use the chain rule. So this implies, what is the derivative of sine y? Is cosine of y. But since they don't match, you need to write an extra y prime, right? Dx over dx is basically 1. So this implies y prime is how much? You divide both sides by cosine y. You see that? If you divide this by cosine of y, you cancel out and then divide this by cosine of y. So basically you get y prime equals to 1 over cosine of y. But the question here is, your question is given as y equals to sine inverse x. Y is defined explicitly in terms of x, but y prime I don't want to write using y, I want to write using x there, okay. So how do I do that is, if you remember that the trig ratio formula, what is the value of sine square y plus cosine of square y? It is always 1, right? If you solve this for cosine square y, what do you get? Subtract sine square y from both sides. Sine square y and then subtract sine square y, sine square y. What do you get? Cosine square y equals to 1 minus sine square y. So the cosine y will be plus minus root under, right? So let me write down that. So it will be cosine y will be, so basically cosine square y is 1 minus sine square y, right? So what will be the cosine y then? Cosine y will be plus and minus root under sine square y, right? Sorry, plus and minus root under 1 minus sine square y. You see that? So that will be 1 minus sine square y, plus minus and then 1 minus sine square y. But do I need to consider both plus and minus? Let's see whether cosine y is positive or negative, okay. we started with y equals to sine inverse x. When y equals to sine inverse x, the value of y is the range will lie between negative pi half and positive pi half. The value of y will be between negative pi half and positive pi half, right? That is negative pi half, that is positive pi half. So this is the range of the sine inverse x, or the value of y in y equals sine inverse x. Now look at that cosine. Cosine will be positive in these two regions, right? The cosine will be positive. So you don't have to consider both plus and minus. You will consider only the plus sign there, okay? So what I'm going to do next is, therefore, I am going to write y prime equals to 1 over cosine y. I am taking the plus 1 only. So you can write 1 minus sine square y. So that is the value of cosine y. So let me write down the in terms of x under the root 1 minus, what is the value of sine y? Sine y is x. So sine square y will be x square. Okay. This is the derivative of sine inverse x. If you do the exact same technique, you will get cosine inverse x. The derivative of cosine inverse x is negative 1 over root under 1 minus x square. They are the same, only the cosine has negative sign, okay? Negative 1 over under the root 1 minus x square. That's what you will get. You see that? Similarly, I want to do for tangent inverse x. Exactly the same technique. I start with y equals to tangent inverse x. This implies if you take tangent on both sides, you will get tangent y equals to tangent and then tangent inverse x. Okay, so that will be just x. Now I want to find out the derivative after that. If you find out the derivative, you will get d tangent y over dx, right, equals to dx over dx. You see that? What does that implies? See, what is the derivative of tangent? It is secant square, but there is y, there is x, so they don't match, meaning you need to multiply by y prime. So it will be secant square y times y prime equals to 1. Now I want to divide both sides by secant square y and then over secant square y. So what do you get? You get that will cancel out, right? So y prime equals to 1 over secant square y. And again, see, our question had x in the right side, so we want to get that x form. So what is the relationship between secant and tangent? Do you remember that? We know that secant square y minus tangent square y equals to 1. If you add tangent square y on both sides, plus tangent square y, that will cancel out. So you will get secant square y equals to 1 plus tangent square y. See that? So I can write this as 1 over 1 plus tangent square y, right? But what is the value of tangent y? That is x. So I can write the final answer for this as 1 plus x squared. This is the derivative of tangent inverse x. If you do exactly the same steps, then you will get the derivative of cotangent inverse x is negative 1 over 1 plus x squared. You see that? And also the last example here on this page I want to take for the formula derivation is find the derivative of y equals to secant inverse x. Okay, so to find out that, what we do as usual, we do y equals to secant inverse x. This implies if you multiply or if you take secant on both sides, you will get secant y equals to x, right? Now we do differentiate. If you differentiate, you will get d over dx secant y equals to dx over dx. I'm differentiating both sides, right? Now see, for the secant, the y and x, they don't match. So if you do that, the derivative formula will be secant y times the tangent y times the y prime equals to 1. Now what I want to do next is I want to divide by secant y times tangent y, secant y times tangent y. Okay, so and then that thing will cancel out. So what you get is y prime equals to 1 over secant y times the tangent y. So you see that one of the interesting thing here is what is y? Y equals to secant inverse x, right? Y equals to secant inverse x. When y is secant inverse x, you see that one. Then what is the value of y? Y will be between 0 and pi. You see that? When y is secant inverse x, the value of y will be between 0 and pi. These are the values of y between 0 and pi, right? So between 0 and pi, right? So that's what the value of secant inverse, when y is secant inverse x, that's where the value of y will be. So in this case, between 0 and pi, what do you see there is, see, if the y falls in the first quadrant, okay, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant, right? If y falls in the first quadrant, then both secant y and tangent y will be positive, right? If y falls in the second quadrant, both secant y and tangent y will be negative. So in this case, you will get both of these are either positive or negative, right? So basically the y prime will be positive. The y prime will be positive there, okay? So let me write one more step here, and then you will see what to write for those secant y and tangent y. For secant y, there is x, right? For tangent y, I want to do exactly the same thing. What did you get from here? The secant square y here, secant square y is basically, what do you get? By the way, I will do this again, okay? Okay, look at here. For secant y, you can plug in x, but we will plug in absolute value of x. We will see why we do that, okay? But what is tangent y? Let me write down that secant square y minus tangent square y equals to 1. So what I want to do here is I want to subtract 1, okay, and then add tangent inverse x, tangent inverse y plus tangent inverse y. So what do you get? You cancel that 1 and 1, you cancel that tangent square y and tangent square y. Basically you will get this. You will get secant square y minus 1 equals to tangent square y. So what is tangent y? Then tangent y will be under the root secant square y minus 1. That's what you will get. Tangent y will be secant square y minus 1, okay? So you can write plus and minus there, but the product of these two must be positive, okay? Because you see that when y equals secant inverse x, the y falls in the first and second quadrant, right? Because the range is that. So if it is in the first quadrant, everything will be positive. If it is in the second quadrant, both secant and tangent will be negative here. In that way, the whole thing will be positive, right? So you can write plus and minus here, okay? You can write plus and minus here. But what you need here is y prime will be the y prime will be positive, because secant and tangent will be either both positive or both negative, because y is secant inverse x and from these range values, okay? So what I'm going to do here is basically I'm going to write this way. So I want to write 1 over secant y times, and then there will be like plus minus under the root secant square y minus 1, okay? So instead of writing both plus and minus, I want to do one thing. The reason here is the product of these two must be positive, right? Either you take secant y is negative and that thing as negative, and then, or secant y is positive and that thing at positive. So instead of writing that, I want to use x. So instead of writing that plus and minus, I want to write this way. In that way, both the product will be positive. For secant y, I want to write mod x, and then under that, I want to write, what is the secant y? It is x and then square minus 1. You see that? So y prime, in that way, for any values of x, you will get positive values. Just the absolute value I use to make sure that we get positive, because the root is always positive, right? Instead of plus minus and secant y, I want to write absolute value of x, so that, because secant y is x, so I want to use absolute value just to make sure that I get positive values in the product, in the denominator. You see that? So same concept, if you use that for the cosecant inverse x, you will get the same value but the negative sign. You will get negative 1 over mod x and then under the root x square minus 1. So this is the formula for cosecant inverse x and the secant inverse x. Okay. So you see that these are all the 6 formula we derived, 3 of them, and we wrote the similar steps. We can get the for the next 3 by using the similar steps. So these formula, look at this. So we are finding d over dx sine inverse x, right? D over dx cosine inverse x. You see that matches? If they match, then those are the formula. But sometimes look at this, d sine inverse u over dx. If they don't match, we write exactly the same formula for sine inverse x, for sine inverse u, and then the extra thing you do is u prime because they don't match, right? So the derivative of sine inverse u with respect to x will be 1 over under the root 1 minus u square times the u prime. The u prime is for not matching u and x. Here we didn't have u prime because they were matching, right? Because you were finding d sine inverse x over dx. You were finding that one here. They were matching. That's why we didn't do u prime there, right? You could do x prime. X prime is 1 basically. Similarly for cosine inverse u, for the cosine inverse, the formula is negative 1 over under the root 1 minus u square, right? And then since they don't match, again this is u prime. For tangent inverse, 1 over 1 plus u square times u prime. So this will be negative 1 over 1 plus u square times u prime. This will be 1 over absolute value of u under the root u square minus 1 and then times u prime. I'm using I'm just replacing x by u there, right? And then negative 1 over absolute value of u under the root u square minus 1 times the u prime. So these are the formula. Okay, so we will be using this formula to solve to find out the derivative of any inverse trig functions. Let's look at this one. You want to find out y prime when y is equals to sine inverse x square. If it was sine inverse x, then the derivative will be 1 over under the root 1 minus x square. But there is x square there. Instead of x, there is x square. So what we do is we assume that as u, right? So basically, I want to find out the derivative, differentiate. So it will be dy over dx is equals to d sine inverse x square. I can write sine inverse u because I assume that as u, right? Let me write down sine inverse u. So d sine inverse u over dx, right? Because there is dx there. So d sine inverse u over dx. But look at that. If there is sine inverse u over dx, then the formula will be 1 over under the root 1 minus u square times there is u prime. Okay. So what is the value of u? U is x square. So I am writing this as 1 over right? 1 over 1 minus u square is how much? U is x square. So that will be x to the 4th, right? Because square of x square is x to the 4th times the 2x. You see that? So what is the final answer? Final answer will be 2x over under the root 1 minus x to the 4th. That is the final answer. Okay. So we will see some more examples here. Okay, guys. So let us see this example that find y prime where y is arc secant 5t cubed. Okay, we will assume that as u. So basically what is given is y equals to secant inverse, that is arc, right? And then u, right? You see that? So let's find out the derivative. If you find out the derivative, then you will get dy over dx equals to d secant inverse, not y. Okay, d secant inverse u over dx. So what is the derivative of secant inverse u? They don't match, right? So the derivative of secant inverse u is 1 over mod u, 1 over absolute value of u, and then times under the root u square minus 1 times the u prime. You see that? Now we plug in the value of u. So what do you get? 1 over 5t cubed absolute value, because that negative u is with negative sign actually, but since this is under the absolute value, it will be positive, right? And then under that is a 5t cubed negative of that square minus 1 times, what is the derivative of u prime? What is the derivative of that? Negative 5 times the derivative of oh, by the way, it should be t, okay, because there is t there, so we need that as t, this one as t, okay, and then this one as t, and then 5, so 3t squared, because the derivative of t cubed is, because we are finding with respect to t, that's why it is 3t squared. So what is the final answer then? It will be, so that 5 will come out 5, because positive 5 will come out, but t cube will stay inside the absolute value. So what I'm going to do here is, let me write one more time, okay, negative 15 t squared over 5 times t cubed, and then under the root, what is, how much is that? Negative 5 times negative 5 is 25, and then t cubed times t cubed will be t to the 6 minus 1. You see that? So very final answer, because this negative times negative will be positive, because you are squaring there, right? So the very final answer will be, you basically divide this 15 by 5 will be 3, right? So your final answer for this problem will be 3t squared negative 3t squared divided by absolute value of t cubed, and then under the root 25 t to the 6 minus 1. That is the final answer. Let's do this one. So this is y equals to sine x times tangent inverse 3x. You see that? So sine x times tangent inverse 3x, that is for y. So we need to do the product rule there, right? Because this is like f, this is like g, and then inside the product rule there will be chain rule also. So what is the y prime? Then it is f prime times g plus f times g prime. See that? What is f prime? Is cosine of x, and you keep g, tangent inverse 3x, right? Plus f is sine x, and then the g prime will be, let me write d over dx, and then so that it will be easy for you to see 3x. You see that? So the first one will be as it is, cosine of x times tangent inverse 3x, you see that, plus sine x. Look at this. This is basically, look at this one. Let me use this color here. This is like d over dx, and then tangent inverse, not x. If it was just tangent inverse x, it will be 1 over 1 plus x squared, right? But there is u, tangent inverse u. So what will be the derivative then? It will be 1 over 1 plus u squared, because the tangent inverse u has the derivative of that, times u prime. But what is u? U is 3x, right? Now let's plug in those values. Cosine of x times tangent inverse 3x, right? Plus this is sine x, so u prime is 3, right? So it will be basically this value is 3, right? Because u is 3x, so u prime will be 3. So 3 sine x divided by 1 plus 3x squared, right? 3x squared. You see that? So your final answer will be cosine of x times tangent inverse 3x plus 3 sine x divided by 1 plus it is 9x squared. This is the final answer. See that? This is the final answer. The next example is find the derivative of y equals to x tangent inverse x plus root under 1 plus x squared. Okay, so what will be y prime? It is like f times g here on the first term, but the second term has just the rule, like you can write 1 plus x squared to the 1/2 for that, right? So y prime will be, so it will be f prime times g is 1 times tangent inverse x plus x times, what is the derivative of tangent inverse x? Is 1 over 1 plus x squared. Since the math right here, tangent inverse x over dx, so that will be 1 over 1 plus x squared, plus I want to write using d over dx, it is like 1 plus x squared to the 1/2. Let me think this as like a u. It is u to the 1/2, right? So u to the 1/2 over x. Let me write on that again. So it is basically this can be written as tangent inverse x plus x over 1 plus x squared plus it is like du to the 1/2 over dx, right? What is the derivative of that? It will be 1/2 u to the 1/2 minus 1 times u prime, right? How much is that? It is 1/2 u to the positive 1/2, because 1/2 minus 1 will be negative 1/2. It is on the top. I move that to the bottom, right? And then what is u prime? U prime is the derivative of 1 plus x squared will be just 2x. 0 plus 2x is just 2x, right? You can cancel 2x and 2. So what you get basically is x over u is what? U to the 1/2 is root u, right? So basically you will get that. So you will get like this. Tangent inverse x plus x over 1 plus x squared plus x over root u. But I want to leave u. I don't want to leave u because the question was in terms of x. So I want to keep the value of u. So the final answer is tangent inverse x, right? Plus x over 1 plus x squared plus x over root under u is root under 1 plus x squared. This is the final answer. You see that? Let's look at the last example. So find the equation of tangent line for arc sine 5x. So what is given is y equals to sine inverse 5x, right? So what will be y prime? Y prime. This is like sine u, right? So 1 over under the root 1 minus u squared, because you can think this as u times u prime, right? Times u prime. So what is u prime though? Let me plug in the values there. 1 over under the root 1 minus u square is 25x square. You see that? Because u is 5x. So times u prime is, because u is 5x, u prime will be just 5. Right? That's what you get. Therefore you get y prime equals to 5 over under the root 1 minus 25x square. That is y prime. But you need to find out y prime at 1 over 10. X is 1 over 10 and y is pi over 6, right? So what is x? Let's plug in the x there. So you will get 5 over under the root 1 minus 25. So what is x? X is 1 over 10. So it will be x squared will be 1 over 100, right? You see that? So this can be written as 5 over under the root 1 minus 25, divide 100 by 25 and 25 by 25. So that will be 4, right? 1 minus 1/4. You see that? This is what you get. So basically you get 5 over under the root 1 minus 1/4 will be 3/4, right? But this can be written as 5 over root 3 divided by root 4. Root 4 is 2. You see that? So it will be 10 over root 3. That is y prime. So what is the final answer then? Y minus, this is basically m, right? So y minus y1 equals to m times x minus x1. So this implies y minus pi over 6, because this is like x1 y1, right? Equals to m is 10 over root 3 times x minus x1 is basically 1 over 10, right? So you simplify that. What do you get? You get y. This implies y equals to 10 over root 3 x minus 1 over root 3, because you need to distribute this to that one. 10 and 10 will cancel out, 1 over root 3 left. 1 over root 3 and then plus pi over 6, because you will have to add this pi over 6 there, right? Because this will be plus pi over 6 and then plus pi over 6. So this is the final answer for this problem. So this is the end of this section 5.7. Okay guys.